Using NL: sends the output to the null device. The null device is used when data is being used for processing and is not being sent anywhere. This option is typically used when the select command is used for populating record structures. We can direct our output to a backend print queue. We can send the output of the select to a file. We will demonstrate this option further as we progress. Another option available is the select into table. This option creates a Discern Explorer table definition. Depending on what organization control option is used, will flex the type of table created. Any organization other than T or P will create a Discern Explorer table. This option creates a file on the backend in CCL IO. This option is not typically used much now. Most clients have moved to domains with multiple backend nodes. Since this process creates the file on just one backend node, that file would not always be accessible when programs are run from the front end and is directed to various backend nodes. Keeping the files in sync for multiple nodes becomes problematic, especially since there is an alternative where this management does not need to occur. Which brings us to the next option. When using an organization control option of T or P, an RDBMS table is created. T creates a temporary table, and P creates a permanent table. These tables are visible no matter what backend node your query or program is run through. So these types of tables require less management for multi-node domains comparatively to a Discern Explorer custom table. The syntax for this select into table command is covered in another lesson. Let's take a further look at the select into file name. This creates a file with the file name provided. If no file extension is provided, the default extension of .dat is used. The file is created in the CCL IO logical path by default. A different path can be provided before the file name. The path can either be a logical path or a fully qualified path. A note on file names and paths. Discern Explorer was originally created on a back-end OS that did not support different casing for file names and paths. When Discern Explorer was made available on back-end operating systems that did allow for mixed casing, the choice was made that Discern Explorer would treat all file names and paths as lowercase. There are ways around this default behavior. However, it is helpful to remember that Discern Explorer sees paths and file names in their lowercase form. Let's look at some uses for creating files. We can use the set spool command to send a file to multiple printers. When running a program and directing output to a printer, you can only select one printer. If you need to send that output to multiple printers, you can write that data to a file and then use the set spool command to send that file to as many backend printers as needed. Here is the syntax for the set spool command. We start off with the set spool command equal to. We then replace string with the full path and file name to the file we want to send to the printer enclosed in quotes. We then follow that with the backend printer queue name. Optionally, we can include spool options following the keyword with. One option available is copy, allowing you to specify how many copies to be sent to the printer. Another option is deleted, to delete the file after it is printed. If the set spool command is included in a program, then go is not needed. If the command is used outside of a program, then go is necessary to issue the command. Here is an example of what this could look like. We have set spool equal to the file name patient.dat enclosed in double quotes. Notice the path to the file is not provided. If no path is provided, then Discern Explorer looks in the current directory, which is typically CCL user. The file name is followed by the backend print queue of LP02. We provide the spool option of copy equals 2 to print 2 copies of the file patient.dat. Another use for creating a file would be to export data to a PC application. Maybe a user needs some data from the system that will be further processed in a spreadsheet program. Or maybe an extract needs to be created to send information to another system. There are several options available to achieve various outcomes. Append can be used to append the results from the current query to an existing file if the file exists. If it exists, the new data is added to the end of the file. If the file does not exist, then the file is created and the data is added to that file. The separator control option can be used to specify the delimiter or separator character between columns of data. You probably have seen this control option used, passing in one blank space. This allowed the displayer to know the end of each column for proper display of the output. You can pass in the pipe character for pipe delimited output. You can pass in a comma for comma delimited output. Or you can use the char function to pass in the decimal ordinal value for a specific character expression. As an example, char 9 will pass the tab character to the separator control option for tab delimited output. Another control option is the format equal to PC format. This is different than using the format control option by itself. Format by itself takes the binary output returned and converts it to user-readable ASCII output. Format equal to PC format builds a typical CSV output. It places commas between fields and wraps double quotes around string fields. If the typical character used for a CSV output will not work, then there is another option that allows more flexibility with defining the required characters. We also have the PC format control option available. This is different than the format control option equal to PC format. The PC format control option by itself allows you to define the quote character, the separator character, and the trim option. Here's an example of what that could look like. In this example, we are passing in the double quotes as our quote character. Notice the caret character is used in place of quotes. The caret character, single quotes, double quotes, and other delimiters can be used to denote character strings. The entire list of string delimiters is contained in the syntax rules using Discern Explorer help pages. We are passing in a comma for our separator character and one for the trim option. Passing in one for the trim option will trim trailing spaces from columns to create variable width columns. To handle variable width columns, we also need to pass in additional information. When using trim option of 1, the format control option is required to define the format stream. That can be stream, CR stream, or LF stream. When using the stream options, we must also include the set modify file stream command before the select command as it enables the use of the stream options. If you find you still need more control over the files being generated, we also have an alternate method of creating output files using the CCL IO function. CCL IO provides access to streaming input and output functions. Let's look further into using CCL IO. Let's start with the benefits of the CCL IO function. It provides more flexibility and functionality related to reading from and writing to files compared to what is available using the Select Into file name. CCL IO can be used in place of other methods for reading from or writing to files, or can be used at the same time to provide additional read-write operations. This could be helpful if your program creates a file using the Select into File Name command. If you need to see additional information while troubleshooting, you could add the CCL IO function to write out a custom log file to provide additional visibility to what the program is doing when it's run, without impacting its ability to write out the file. CCL IO allows you to write lines with more than 32,000 characters to a file. The Select into File Name option limits each line to 32,000 characters. This can make writing out large amounts of data challenging, particularly blobs or binary large object data that could extend across multiple lines and multiple pages. Every 60 lines, a page break is issued. This can cause additional challenges when reading the blob back in, as you would need to remove carriage returns and page breaks that were not present in the original blob. With CCL IO, you can write individual lines or the entire contents to a file starting at the start or the end of the file. Also, you can read an entire file or individual lines from a file, again, starting at the beginning or the end of the file. With CCL IO, you can control if you are writing one line at a time or a combined set of data. Writing combined data using a single write command consumes less I/O operations and is probably more efficient than writing each individual line. The syntax for CCL IO requires to pass in a function name as the first parameter. This function name defines the type of operation to be performed. Some examples are open, close, and write. The second parameter is the record name. This record structure contains several elements that the CCL IO uses to process the requested function. We will see what that record structure looks like shortly. You will want to refer to the documentation for CCL IO to know what functions are available and to get the record structure definition. This document is a useful resource when working with output files. It breaks down the various stream options and what they allow for when applying end-of-line characters. This document also contains a full example program that demonstrates writing a file using CCL IO. Here is the record structure definition that meets the requirement of CCL IO. The record structure can be named differently, but the contents must be the same. Most people copy this exact definition from the documentation for CCL IO and use it as it is. There are two items that we will use in this record structure definition to write a file. First is the file name element, which allows us to provide the name of the file. The second is the file buff element that will be the buffer used for reading and writing. Let's break down the steps necessary to write data to a file using CCL IO. We start with opening the file. This will generally be done before the select command. We then need to set some values in our control record structure. Here we set the file name to cclfile.dat. Next, we set the buffer to W. This lets the system know that we want to open this file for write access positioned at the start of the file. We then pass the open function along with the frec, which is the record structure that contains the file name, and the W in the buffer field. The return value from CCL IO will be placed in the stat variable. 0 indicates an error, 1 indicates success. Now that the file is open, we can shift our focus to preparing what we will write in the file. The write operation is often done in Report Writer, but can be done outside of a select command. In this example, we are creating our own CSV style output. We have defined a variable to contain the quote character, double quotes in this example, and a variable for our separator character, which is a comma in this example. Processing of data will take place in the detail section as we go row by row through the result set. Notice we are populating the data into the file buff element in the FREC record structure. We are using the build function to string together several numbers and strings of text into one larger string of text. In this example, we have person ID, comma, quote, nameful formatted, quote, comma, quote, birth date, quote, then char 13 and char 10 to add a carriage return and a line feed to the end of this line. Concatenating these fields together creates a line that has double quotes wrapped around the nameful formatted and birth date fields, and then place a comma between each field. We are then going to pass the puts function along with the FREC record structure to write that line of data to the file. Again, we are placing the return value in the stat variable. 0 indicates an error and 1 indicates success. We are almost done. We need to close the file. This is generally done after the select command. We can pass the close function along with the FREC structure name to the CCL IO function. That will close the file. There you have it. The file has now been written. Let's look at the full example. This example makes use of the select into file name command to generate output. We wanted to see some additional logging generated while this program was running. So we used CCL IO to write that out to a custom error log file. This technique can be helpful when you need to see runtime information as a program is run. This is particularly useful for programs run through system operations or from within PowerChart. This can also be useful when investigating issues where a certain program randomly is not working as expected. You could write out relevant variables and other values that can help you see what scenarios are failing. We still start off with creating the FREC record structure. Remember, this record structure is necessary for the CCL IO function. There is some base information that we need to populate in that record structure. First piece is the file name that is used for writing the information. Next, we will pass in A+. This option allows to open the text file for read-write access positioned at the end of the file. If the file does not exist, then it will create the file. If the file already exists, then it will append new information to the end of the file. When passing in the open mode, we will always use lowercase characters. Then we will call CCL IO, passing the open function and the FREC record structure. This opens the file. We pass in a blank space to clear the buffer. We are now ready to write to this file using CCL IO. Now we need to create an error so that we have something to write out to the error log file. This select is creating a file, so the logging we are after could not be created using the select into file name command. We intentionally spelled the personnel table name incorrectly by adding a 1 on the end to cause a runtime error. This will create a CCL-E-18 table doesn't exist error message. We call the getErrors subroutine. We use this subroutine to pull errors from the error stack so that we can write them to our custom error log file. Let's jump down to the subroutine. We are using the combined syntax for creating the subroutine. We are passing in one parameter with no value being returned. We have two variables for use in processing errors from the error stack. The first one is for the error message. We defined it as a VC. As of 8.2.1, the error message size was increased, so VC should work fine. The next variable will hold the error code. Error code is defined as an I4 using the no constant declare option to set the initial value. To set that value, the error function is called, passing in the error message variable to write the error message and a 0 as the second parameter to indicate to not reset the error stack. This pulls the error at the top of the error stack. The error stack can contain up to 5 errors. The first 4 encountered and then the last error. The last error is at the top of the error stack. Passing in 0 for the second parameter will clear the error that was just pulled from the stack. Passing in 1 for the second parameter clears the entire error stack. This would be a good time to inform you that the error function should not be used in programs to run from system operations, particularly those that use the 305-3000 and 305-3001 templates. These templates use the error function to determine if the program ran successfully. If your program pulls all of the errors off the error stack, then these templates would report to system operations that the program ran successfully. Other templates may use similar logic, so be aware. Now that the two error handling variables are declared, if an error has occurred up to this point in the program, then the message would now be sitting in the error message variable, and the error code variable would contain the error number. Both variables were populated by calling the error function. Next, we create a while loop that keeps processing as long as a value other than 0 is in the error code variable. We should have an 18 sitting in that variable the first time through because of the error we caused in the select command above. The error will push the processing to the while loop commands. We create error logging by placing the following into the buffer field in the FREC record structure. Using concat, we string together multiple strings of text. We start off with the buffer field. That way, if we have already placed an error in there, we will add the next one after the previous error. Then the text of an error occurred while executing, followed by one blank space. Then the current program's name, followed by a blank space. Then char 13 and char 10 to put in a carriage return and a line feed. We follow that with the text of error number, colon, blank space. Format the error code specifically left justify it. This will convert it to a string of text that will be trimmed of trailing spaces. One more blank space, the text of the error message, another carriage return, and a line feed. We are done processing that one error. We now need to see if there are more errors in the error stack. Call the error function again and populate the next error code and error message if another error exists. If not, then the error code is set to 0. If we pulled an actual error, then the while loop processes again to write that error to the buffer. If not, then we will break out of the while loop. This program should only have had the one error. Let's return to where we called the subroutine. We will call CCL IO to perform the write function to write all of the data in the buffer field into our file. Now that we are done with the file, we can close it by passing the close function to CCL IO. That's it. We've written out errors to the custom error log file. Next step is looking at the contents of the file. There are several options for opening the custom error log file we just created. We could open it in dvdev the same way that we would open a source code file saved to the backend. In a multi-node domain, you will need to select the appropriate backend node that the file was written to. Another option is to use the CCL read file node program to open the file. This can be helpful as it will open the file using the Discern Output Viewer component. This is particularly useful when opening files that require rendering to see the output, like PDF or HTML. The CCL Read File node program can be found in DVDev in the Report menu. You can also run it as a prompt program through the Build menu. If you are on older code, then you may only have access to the older version of this program, CCL Read File. That program does not allow you to select the backend node, so it is less effective in a multi-node domain. Here is the prompt form for CCL Read File node. Typically, you only need to fill in the file name in the Enter String Log Name field and select the host name for the backend host where the file resides. If we open the custom log file, 1cclefile.dat, we can see the logging that was written to the file. Thank you for joining this discussion on using Select Into and creating files using the CCL IO function.